it looks like, Bob and Michael, you are our two star guests here. So thank you very much.
They're both awesome. They're both awesome people.
Yeah, thanks for joining us.
We're very happy to have you two here. Hopefully you guys find this presentation informational. Karol has done some really awesome work she's about to present, but first let me give you a little introduction to Karol. So today we're going to go ahead and just do a little introduction for Karol. She's going to do the presentation. You guys are going to have a chance to do some question and answers with her if you have any questions, and then we'll talk about our next presentation. So Karol Francis, she works here at Gistic. She's going to be giving her presentation titled Resurrecting the State Highway Logs. And it's really about the FME process that generates both summary and detailed highway logs from the 25 or 26 different event tables inside of the Esri Roads and Highways database here in Arizona for the Arizona Department of Transportation. Her favorite transformer is the Voronoi diagrammer, and her least favorite food are mushrooms. So with that, Karol, I think I'll turn it over to you and you can hop right in. I might have to make you a co-presenter.
Yeah, it says you've disabled screen sharing.
Bo, I think you're actually the host here. Can you make in the presenter list, give Karol the rights to share?
We should be the co-host
now. Okay. Do you guys see my screen?
Yes.
Yes.
Great. It's a little weird with Zoom because I can't see what you see. Okay, so hi everybody. John introduced me. I'm Karol. I work at Gistic. And yeah, I'm here to talk to you about our highway log processes. So for those of you who are unfamiliar with these logs, a summary log is a summary of centerline, lane mile, and maintenance lane miles within a state. A detailed log is a complete inventory of DOT-owned assets within a state. And ADOT published these logs annually for decades until they implemented roads and highways in 2015. And the implementation of roads and highways was enormously disruptive to their existing workflows for the creation of their highway logs, and they no longer worked at all. And about a year and a half ago, ADOT approached Gistic and asked us to help them resurrect their highway log program. And so first, I'll give you a brief overview of the summary log process I developed, and then I'll dive deeper into the detail log process. Relatively speaking, the summary log process is pretty straightforward. It performs a series of overlays on 17 feature classes, and the output of these overlays allow us to add up center line miles, lane miles, auxiliary lane miles, including shoulders and bike lanes, and maintenance lane miles. And all of these are divvied up by routes, engineering districts, county boundaries, and federal land ownership. This process spits out 480 nice and tidy non-spatial records into a SQL table. The SQL table is used to populate the Tableau dashboard and SQL Server reporting services. Both of these platforms offer self-service. They're both self-service platforms for users, and the users may use these to dial into the dimensions that they are needing information about. The SSRS platform also allows for the generation of PDF reports for anybody who wants a paper version. And so this is what the end users see for the summary logs. This is a screenshot of the centerline Tableau dashboard. The users may use the, where's my thing over here? Yeah, my laser's not working. This is what the end user, oh wait, I'm hitting the wrong button. So they can use the group by radio buttons to choose the dimension displayed. And they can toggle between tabular and bar chart views of this data set. And the lane miles dashboard is similar graphically, but it displays lane miles and maintenance lane miles. And this is what the SSRS report looks like on the server. We are currently in process of publishing the PDF output from this SSRS onto the ADOT website, where it will be available for the general public and anybody to view. Okay, and now I'd like to talk to you about my baby, the detail log process. This thing is a beast. It reads 25 data sources. 23 of those are shapefiles or feature classes, and 2 of them are flat lookup tables. It uses 318 transformers to generate about 40,000 records that are written both to ArcGIS Online and to a table on our SQL server. The output is then consumed by SSRS and an Esri dashboard. And that Esri dashboard is actually embedded in an experience builder. The flowchart illustrates the process flow. First, we do an overlay of all linear full coverage events with ADOT-owned routes to define the scope of the process. Then we convert the linear events that are not full coverage and polygonal boundaries to points with length attributes, and then we mix those in with the true point feature classes and do an event point online overlay with the output of the previous overlay process. Then we tidy up that output and write to our AZGO ArcGIS Online feature service and our SQL database. Excuse me. As illustrated on the flowchart in the previous slide, the data read into this process falls into 6 categories. There's linear full coverage feature classes, linear not full coverage feature classes, our point layers, our route network, including carriageway descriptors and ownership, route ownership. We have boundaries, including polygonal and event layers. And then we also have a couple of lookup tables that we use to enhance the domains that exist in the Roads and Highways database. For each input group, the data is read, the columns are standardized in preparation for the next processing steps. So ADOT has this wonderful feature class called the carriageway feature class, and it includes important information, including route cardinality, route types such as mainline, ramp, or frontage, as well as shortened route names that are much easier to digest than their standard 32-character route ID. However, this feature class covers highways and local routes, regardless of route ownership. To find ADOT-owned carriageways, we do an event overlay with ADOT-owned routes from the ownership layer. All data in the detail log is overlaid with these ADOT-owned routes to limit the output to the scope of the detail log. So then we start our event overlays outside of defining the scope. If a feature class has full coverage, meaning it covers the entire route network, we combine all records into one stream. First, we standardize the columns in the data stream, and then we send the entire data stream to an overlay process where the stream overlays with itself. We call this the single stream overlay, and this was developed, we accomplished this using a custom transformer that Bo developed, and this transformer is available for download on the FME Hub. The resultant output is a series of events where each event describes the shoulder surface, pavement type, number of through lane, shoulder width, surface width, and the length of that event. The screenshot is only a tiny sampling of the output of this massive overlay of 6 feature classes. And I mentioned this on a previous slide, we pull a bit of an interesting stunt in this process. Every data source that is not a full coverage event, feature class is treated as a point. We convert lines and polygons to points and throw them in the event point online overlay process with the true point feature classes. This works because we capture the length of each event. So when it is displayed in the output, the linear or polygonal point has a measure and a length. And this table illustrates what the linear non-full coverage events look like after being converted to points. The symbol column is populated with the lookup table that gives an abbreviation for every source feature class name. So here we have slow vehicle pullout, left turn lane, right turn lane, left turn lane, another slow vehicle pullout. The data column describes the event with more textual information that's a little more human readable. So there are 6 feature classes with actual point geometry used in this process. 3 of them require some more involved processing. The most difficult of those 3 is identifying where a road crosses both the cardinal and the non-cardinal sides of the main line. ADOT calls these ambicardinal intersections. So that's this yellow line in my little diagram. The carriageway feature class tells us which routes are ambicardinal to the SHS routes that are displayed in the detail log. The problem is that the measures that identify these crossings are on the ambicardinal routes, but we need the measure on the main line where the ambicardinal route crosses. Well, the junction table contains the measures on both routes at these intersections. So we swapped the cross measure and the carrying measure using the junction table. Then we overlaid that output with the ADOT owned ambicardinal routes. This output goes into the event point online overlay. The remaining point pre-processing isn't nearly as interesting, so I'll spare you the boring details on those. Okay, so finally, all point streams are combined, and this point stream goes into an event point online overlayer. And this is also a custom transformer that Bo developed, and it's available on the hub. So this point stream is overlaid with all linear full coverage events, and that was the output of that single stream overlay process. The output of this part of the process is in event point format with a measure and a length value. We use a quick SQL script to obtain milepost and offset attribution and a bit of attribute cleanup, such as deleting duplicate spaces caused by field concatenation, specifically in that data column, because it's made by concatenating several fields in the source data together. Now we have a detail log where every important asset on ADA routes is marked with a point. This screenshot illustrates the final attributes and schema. The various point, not full coverage feature classes and polygons are captured with the symbol and data columns. Every segment of roadway contains these attributes that are derived from the full coverage feature classes. And then the features that have null length values were derived from true point feature classes that have no length attribution. And at this stage of the process, the data is ready to write to the non-spatial SQL table. However, our event points are currently non-spatial at this stage of the process. So we geocode to obtain point event geometry, and we do a bit of tidying and standardizing before writing to the ArcGIS online feature class. And this is what our output dashboard looks like. And there are 2 data product outputs of this process that are accessible to the users. The first is the dashboard, and the second is a PDF, and they are both available from the experience builder. So now we can take a look at this. And so John actually took the dashboard I built and dropped it into the experience builder, and it's kind of this amazing thing now. The users initially greeted with a data disclaimer that tells them appropriate uses of this dashboard. I see somebody's chatting. Oh, thank you, John. And so it gives you important information about appropriate use and lets them know that we tried our best to do accurate representation, but there may be mistakes in here. And so you can close that. And then on the left side, there's a supplemental information. And from here, you can download the PDF document, and it's about 1,200 pages. It's enormous. And there is a YouTube video tutorial that introduces this product and gives some brief instructions. And I created this video and published it on YouTube. So if you watch it, you will hear my voice again. And then we also have a series of tables that describe or define all of the abbreviations that are in this data table. So we can close this thing and we can choose a route of interest. I'm going to choose State Route 77 and milepost 77. And the only reason for this is because it's near where I grew up. And so from here, we can zoom around and the table updates as we pan around on the mouse. if we want specific information or, like a pop-up of a point, we can click on it and it's highlighted on the map and we get this pop-up that contains all the tabular data. Oh gosh, I made it so tiny. Let's see if I can bring it back. And then the user can also toggle between cardinal and non-cardinal routes. And you can see that the table updates. I don't know why it shows that is selected. And the users can also choose a specific symbol type. So if somebody was looking for all structures on State Route 77, they could filter this down. It would only display those. And so that's the user interface. And if the user finds a problem here, and there very well may be problems. We have tons of QC built into the FME process, but that doesn't mean we caught everything. And it doesn't mean that everything we caught was fixed, because there are business needs that ADOT has to balance. And, even though we would like perfect data, we live in the real world and we know that there are definitely data bugs out there. So the user can first check to see if their problem has already been reported. And if it hasn't been reported, they can report the issue using this Survey 123 application that John built. And so they fill out their name and email address, and they can give us information about it and hit the submit button, and then we know we have a problem that needs to be fixed. And that is my detail log. I don't really have a lot more to say about it. It looks very simple right now, but it took about 1.5 years to develop this process. It was really a pretty intense thing.
Karol, thanks for that great presentation. Well, one question I have for you is, in your mind, what was the hardest part of this entire process, from like start to finish?
Oh, that is not an easy question to answer, because I went into this not knowing what a highway log was in any way, shape, or form. I'd never seen one or touched one or used one. And so the difference between a summary log and a detail log was incredibly confusing to me. So once I found old ADOT documentation that was, the most recent was from 2015, and that one actually had some issues. So I had to go back to the 2009, and then, just understanding the scope of the process was hard enough. But then determining which feature class to use to get which attribute was monumental. That was really hard. There are 25 data sets that go into this thing, and determining which columns we use from the source that go into which column in the output was just, it was hard. It was really hard. I mean, we had, of course, there's an incredible team at ADOT that was ready to answer any question I had, and we have extensive documentation, but, it was just the scope of this thing was, I would say, the scope of the process and understanding the process.
Gotcha.
Would be the short answer. Yeah.
Well, one of the things you mentioned was the summary log, and I know you showed the Tableau version. And currently you're in the process of converting that to Google Data Studio, right?
Yeah. Yeah, that dashboard's kind of in its infancy. It's just tabular. And as good as Google is with maps, with Google Maps, their Data Studio visualization product doesn't really have a great map interface. So it doesn't really work with spatial data. So we have a developer within Gistic who is working on developing a spatial plugin essentially for the Google Data Studio dashboard, so that we can add a spatial component to that.
Gotcha. Can you go back to the ADOT PDF of the detail log and show a little bit of what that looks like? I actually did embed the summary logs in here already and updated it, so you can.
Oh, you did. You've been very busy today. Yeah. So, so this document, yeah, this thing was actually a joint effort between John and me. John did a lot of the stitching together of various PDF outputs to make one master document. And he created this title page, and then we have our data disclaimer. And this is the same data disclaimer that's on the dashboard. And so it actually, this combines the summary process outputs with the detail log process. So we have center line miles by route, And if you scroll through all the routes, then you get through lane miles by route, and you can continue all this through our different dimensions. We have routes, and there's, this thing's huge. Districts, counties, and federal land are the different dimensions that we have. And then let me scroll down to the detail. I am in the detail log now. See, I-40. Ooh, no, not. Oh gosh. Okay. Way too far. What's there?
Yeah, it scrolls really, really fast. 1,200
Yeah.
pages.
Yeah, it's either going way too slow or way too fast. Okay, here it is. Okay, so then when we get to the detail log, we have all these tables, and these tables are also exist in the Experience Builder dashboard. But this gives all the definitions for the different abbreviations that are in this detail log, and there's a lot of them. And then here's the detail log. So John built the SSRS that generates this PDF, and he put some custom coding in here so that if there is no data where there should be data, it turns red. There is some custom coding so that if the data column starts to word wrap, it shrinks the font size to minimize that word wrapping to keep our table tidier and shorter. Let's see. Yeah. Each page has the route and the milepost range that's displayed on the page. It's a pretty humongous document. Anything else you'd like to point out, John?
No, I just wanted to show that, you know, what we display in the table or in the dashboard is totally congruent with what we've displayed in the static PDF version.
Yeah.
With the intention that the dashboard will always be a live, up-to-date copy of it, and we'll retain historical copies of these printed logs in case people need to go back and reference where things were in the past.
Yeah, and Eric, to answer your question, are we using FME with SSRS? Indirectly. So we take our FME writes to a SQL table, and then SSRS reads that SQL table. We currently only have FME desktop available to us. We don't have FME server. So there are some database communications that are a little bit clunkier than they could be, less automated.
Absolutely. Does anyone else have any questions for Karol?
Not necessarily
Yes.
a question, but a comment. I work with Eric at GeoDecisions and David, and I was involved with ADOT's after they went to Roads and Highways. I worked on their project for HPMS, and so I know at that time they were, you know, this highway log was something that was very important to them, and you know they had no way to produce it directly out of Roads and Highways, and you know we had looked. You know, we were doing HPMS work, but we had sort of looked at what was available. And, you know, at that time, Esri's roadway reporter hadn't been released yet. But I doubt that they would be able to create something like this with their roadway reporter. It's probably would be not as nice and not do exactly what Arizona likes. So I think it looks really great.
Yeah, thank you. Yeah, that was actually one of the first things we did is we tried to use Roadway Reporter to generate this thing, and we were absolutely unable to.
Yeah.
And, you know, I'm sure part of that was me actually not really understanding what a highway log was at that point in time. But also it's just Roadway Reporter is just not capable of doing this. Not with the very defined columns and concatenating fields to make the data column and all that stuff.
Yeah, I think you can pretty much produce a highway log exactly the one way that Roadway Reporter will do it, and that's it.
Yeah, exactly. Yeah, so Bo asked, could we talk about how we validated the highway log? So validation was actually really intense. We have before even publishing and creating the output, we have so many data validation steps baked into the FME process. So we check to make sure that if you have a structure, it actually has, if you have a bridge, sorry, that goes over a roadway, we check to make sure that there's actually clearance under that structure. We check to make sure that there are through lanes for every bit of roadway, that shoulders are, all the full coverage data sets exist on every bit of roadway. And if they don't, we kick it out to a QC report. Gosh, what else? There's just so many QC steps baked in. And then once we got the data to a point where we felt like, okay, this is an accurate enough reflection of reality that we're ready to publish this thing, we then, wrote it to our dashboard and the PDF. And from the dashboard and PDF, we compared the output of that between our dashboard, Google Maps, Google Street View, the internal, oh gosh, what is it called? Bo, help me out here. What is the photo log, the ADOT photo log?
iVision.
iVision, thank you. Thank you. iVision, which is a product that ADOT has, it's actually very similar to Google Street View, but it also, it correlates images to the roads and highways records. And then we also made some maps, a bookmarked MXD document in ArcGIS where we added all these feature classes and just made sure, are we including everything we need to include? Are our records showing up where they're supposed to with the correct measure and milepost and offset and stuff? And we found many bugs in the FME process doing this. For example, one thing we found was that I misinterpreted something that ADOT told me about their structures data set. And I added a filter when we were reading that structures data set into FME, and I was excluding the majority of the records because I misunderstood the application of this filter. So once I removed that filter, then all of a sudden we had all of our structures where we needed them to be.
I would like to add the importance of QA/QC throughout the process. In fact, this highway log process become one of the key catalysts to clean up the roads and highway database inside ADA's entire kind of editing group. And I think last time John was talking about the dynamic dashboard, editing dashboard. That's part of what kind of essentially the process to support a quality product such as this.
Yeah, and that's a really good point, Bo. Unfortunately, I don't have the statistics on this, but the feedback we got when ADOT submitted their HPMS last summer was that the process was much more straightforward and there was less troubleshooting because our QC, our built-in QC in the FME process sort of forced them to clean up so much of their data. So it was just easier for them to do their HPMS submittal. But I don't know exactly how much easier, but it was significant enough that they told us.
And I would like to add one more thing about this process, because what we have built is not just a product. We have built a process. This process would allow us to essentially creating log pretty much any time. I think most recently, as of yesterday, we have decided to do biannual, essentially 2 times a year to produce this. So in a sense, it's going to be one-time investment, and down the road is basically a simple maintenance and click a few buttons, getting things done.
Yeah, but I believe you're absolutely correct in that. I think one of the benefits to what we've created here is that it has ultimate reusability. And so we can generate a report at the end of HPMS submittals to represent what that data year or data cycle was. And then I believe ADA also wanted a mid-year report sometime in February, if I'm correct, kind of what their data looks like at that time. So I believe we'll be making 2 versions of this and publishing it, roughly every 6-ish months or so. So that should be, it should be very easygoing moving forward now that we've created the entire process.
Yeah, it should be. One thing that I didn't mention in my presentation is we recently discovered, well, more like John showed us recently, that we can use the Roads and Highways archive tables in order to go back in time. So we are actually able to run this process so that it temporally it's in line with the day the data was pulled for the HPMS submittal last summer. So we're able to make it, it's not just on live data, which is proving to be very useful and powerful for ADOT.
Absolutely. Does anyone else have any questions, comments, feedback? Okay, well, with that, thank you very much, Carol, for your hard work and putting this presentation together. And next month, we will be having David Runnels from Geodecisions presenting on his FME best practices. Unfortunately, he had to leave a bit early from this meeting to run to a different meeting. So you'll have to wait for that post to come out to learn more about that, but it should be a very good presentation. I know David is both an FME desktop and server certified professional, and I've seen some of his work, and so I think his best practices are going to be very useful for everyone. I'm going to go ahead and stop sharing and end this recording, and thanks everyone for attending.
Yeah, thanks.
Hey,
Good job,
Eric,
John.
John and Carol, can we